So this is Dr. A.K. Mahbubur Rahman. I am the assistant professor from Independent University, Bangladesh. And we are working with Kian Cheng and Sivasaki from Tokyo, Japan, and other collaboration from University of Dhaka. Um, okay, so as you everybody know that Bangladesh is a developing country. So this paper actually is concentrating on the urban categorization method or urban environment categorization method for the developing cities. Okay, so why we are interested about this paper. The first thing is the understanding the urban environment. So for the UN, United Nations, and all of the organizations, most of them are very aware of the sustainable development goals. It includes no poverty, zero hunger, good health and well-being, quality education, and all other things. So to implement these sustainable development goals, to achieve these goals, we should understand the urban environment very easily and in a very scalable way. Like that, for whole Dhaka, we need some map, or we need some technology to get information about those um, socio-economic information or socio-economic conditions. Here, for example, this is the urban population living in slums, or the percentage of the slum living population. So if you can see that the color here, if you look that these are very high in the African region, and here this is Bangladesh. So you can see this is small country, one of the developing countries here. So it is almost 70 to 80%, and most of the slum living people are living in the urban area. Okay, but the problem is that these are the data had been collected based on the census and community survey. Those are very time consuming, uh, very much expensive, because so many people need to be employed to collect all those data, and it is not a scalable solution, because the thing is that you need a very large organization or very large implementation to collect all of the data. Okay, so we are looking for some machine learning technology to do it automatically for us. So this is the one kind of a very overview. Like for example, here this is the Dhaka map, and these are very good buildings, well-structured building. And in the middle, there are some undeveloped area in the urban settings. There is a road there. So we are trying to understand this kind of urban environment automatically from the satellite. Okay, so understand these are the different kind of area or urban settings are here. Outside, there are different kind of settings are here. These are the goal for the why it is important. The economic condition, the poverty, environmental, like the residential area. What is the environmental of the industry area, or is there any land problem is there, or is there any slum is there. Also the governance planning. So if we have map like that, like they need to develop something in the urban, so the government can take initiative with the land management, planning, the intervention and growth models and urban growth. Also some social, like where we need to put the sanitation, where we need to put the hospitals and all those things. Okay, so these are the things actually should be implemented through the automatic categorization of the urban pattern. However, there are some no, categorization, this kind of categorization, those are actually studied for the developed countries where there is, where there is the residential area is very much formal. The marketing area is very much formal. Industrial area is very much separated from the residential area. The building materials are almost same because I studied at USA, so I found that the residential area, the neighborhoods, all are mostly same. Building materials are same in those areas. In the industrial area, those are very separated from the other area. The commercial area, very big buildings are there. So for this kind of developed countries, it is very easy to get those information from the satellite images. The problem is for the developing cities in the challenges are in different things. For example, the building materials, those are very, very different building materials are there. We will see later. It is ranges from bamboo-like roofs, polyethylene roofs to the concrete roofs. Okay. Surrounding environment. In the earlier urban patterns, they only account the building structure for the urban pattern. But in the developing countries, the building structure are surrounded by different kinds of environment or urban structure. We should understand that environment together. For example, if there is a slum, so the environment has a very unique properties like that cheap material, cheap building materials, low access of roads, high density. But it is very different from the well-developed area because the concrete buildings are there, the buildings are very well defined, the roofs are very well defined, square and all those things. Moreover, the slum or very underdeveloped areas might be there is a small kind of trees. There are trees beside the slum. There is water beside the or lowland or marshland beside the slum. So for the developing countries, we should understand the urban pattern by including the environment here. Okay, because by looking at to the single inhabited or single building might not be sufficient to categorize the pattern. Okay. um, and also we don't have any dedicated residential area, industrial area and marketplace. For example, if you look like this, so this is the so if you look in the right way, so this is the very well developed buildings are there. But here in the bottom, there are slum or less developed area here there. So this area should be categorized as slum or low developed or underdeveloped area by looking in the environment or looking in the surrounding, not by looking to the individual buildings, unlike the developed country. Here, if you look at there here, so very shanty way here. So we should make our method in a way that we can categorize this information in a holistic way. So how the novel categorization is different. So the earlier they use a single criterion like a density, the building density, orientation, index, building size and height. But in our proposed novel categorization, because the environment is much more important now, so we classify it, we are categorizing it into two different axes. The one axis is here in the building quality, architectural, and this is the road generation. So how the roads are building. So here, if you go to the top, more structured way the buildings are created. From left to right, it is in the left it is naturally, the roads are naturally generated, then that is going to the planned way. Okay, so in the two axes, we can make our categorization much better for the developing area. So if we look into in a clear view, so these are the 16 categories. Those are actually we make our category for the developing area. So here the natural generation, plant outside outline. So here in this area, the roads are outside are plant, but inside, no, not that kind of plant road here. Outside are not plant, but inside the roads are plant, and the last one is the road or plant way, plant road. Here we are looking into the buildings or as a single unit. So in this axis. So here it is none. So there is no code for buildings. This is a limited code. Here is there is some code, right? Here is some code, and here with code, fully with code. So there are a couple of advantages by looking the urban area in this way. For example, these categories are, you can say, as a building block. So there are 16 categories for now. So we can see, say that these are the 16 elements or building blocks, so that we can take those elements to segment a urban area, very big urban area. Also, what we can do that, also we can use these categories to go for some abstract level. For example, we will see later. Okay, let's go to the later. So advantage, the urban environment, and these are very much applicable for any developing cities. It is suitable for deep learning methods that we will go further. We will show automation because it will support big scale implementation, different level of abstraction. So one level of abstraction is the building itself. The second one is we make four different area for socio-economic condition. One is highly informal area, moderately informal area, moderately formal area, and highly formal area. If you can see, the red area in the lower part, these includes the highly informal area, the slums, and all those things fit into this area. Then the these are the moderately informal area. So this area, the buildings are the peoples are moderately, they earn money, but their buildings are not up to the mark. Then the cyan, who has a very good condition and some good road condition there. And the finally the blue, it is the most desert area or more structured area, where highly formal area. They have very good structured streets, street access, and also the buildings are coded, the buildings are uniquely identified. So this is the second level of abstraction for the socio-economic condition. Okay, so now we will apply our concept to for the Dhaka city. So this is the whole image from the satellite image for Dhaka. So we downloaded the Bing image where 2.25 meter per pixel, the resolution is there. This is the whole Dhaka area, and we make the ground truth here. So we visually ground to check our model and to investigate how the deep learning works for our proposed categorization technique. So here we visually make the ground truth here. So the red is the highly informal area. These are the red. We call it arriving city or city arrivals. Those are very poor. Slums are here. Cyan, moderately informal area. Green, the moderately formal area, and blue, the formal area. Okay. So now we have a clear objective. We have to segment it properly. If you can do that, how good the state of the art deep lab v3 plus segmentation library to segment Dhaka city with these socio-economic conditions. So here we use a deep lab v3 plus architecture, because you all know it has a Atrous convolution here. And for the Atrous, they can see the roof, they can see the different kind of structure in um, very in a good way. So this is the process for trading. So we're passing the input image and passing the ground truth image, and we are using the 70% overlap into two dimension to learn easily. And these are the performance measure that actually um, we are interested with accuracy, IOU score, recall, and precision. Okay, and this is the testing city. So this is the testing part. 30%, so 70% Dhaka city we use for training and 30% for testing. And this is the ground truth for Dhaka, and this is the result. So if you can see that this is the result for this is the ground truth, this is the input, and this is the output from our model. And if you can see the red area, the highly informal area, it is 86%. We can segment it properly. With IOU is 49, with class 2 with 83% of accuracy, class 3 with 94% accuracy, and class 4 is 99% accuracy. So the contribution here, the novel categorization, the different level of abstraction. So we can use it in different level of abstraction with defined way. So what kind of level you know that. Uh, this which we have shown that the process is very much suitable for deep learning models, and we can make it usable for automatic socioeconomic area segmentation. So this is my presentation, and I think I got some bail. Maybe I am out of time. So thank you.